All right. Unit 1, Topic 3, the laws of exponents. The first law of exponent we're going to be looking at is multiplying exponents. So now, if we look at this, it says if I had 2 to the third times 2 to the fifth, well, what we can say is that it's 2 to the third is 2 times 2 times 2. 2 to the fifth is 2 times 2 times 2 times 2 times 2. So what we got here is we have 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 too. So this can be 2 to the 8th power. So how about this one? Well, x to the fifth. Well, this is x times x times x times x times x. And then x to the 10th is x times x times x. And 10. So now if we would count these, well, we have this is x to the fifth and this is x to the 10th. Well, there's a total of 15 of these. So this is going to give me x to the 15th. Now, is there an easier way that I can multiply exponents? Yeah, there's a lot easier way than writing them all out. But this is the underlying rule where if we write them out, we can add them all up. But the easier way is our product of powers property. Well, what this says is that the product of two expressions with the same base, so they have to have the same base, equals the base raised to the power of the sum of the exponents. Well, sum means to add. So we take the base and we add our exponents. So this first example, we have x to the a times x to the b, which is going to give us x to the a plus b. Or our numerical one, we have 4 to the second times 4 to the ninth. That'll give us 4 to the 2 plus 9, which is 4 to the 11th. And then this is the why does it work, which we just went over why it works. And now if we look at a couple examples, we have try these. Well, what we want is we have 10 to the third. These are the same base, so we can add the exponents. 3 plus 8 is 10 to the 11th. And later on we'll get into evaluating what 10 to the 11th means. So 7 to the third and 7 to the fifth, same base. So we have 3 plus 5, which is 7 to the 8th. X to the 11th, x to the 9th, they have the same base. So we do 11 plus 9, x to the 20th. 6 to the 4th and 6 to the 2nd, they have the same base. So we have 6 to the 4 plus 2, which is 6 to the 6th. Now when we look at E, well, we have a to the 6th and a. Well, this is just another way to say time. So we're multiplying our bases. Well, we can put this exponent as 1 because there's one a there. So it has the exponent of 1. So a to the 6th times a to the 1st, they have the same bases, so we can add them. 6 plus 1 will give us a to the 7th. And if we look at the next one, well, once again, this means to multiply. So x squared times x to the 7th. We can add 2 plus 7, which gives us x to the 9th. And then with g, well, we have 5 to the third, and this is 5 to the first power again. Well, they have the same base of 5, so we can add our exponents, which will give us 5 to the 4th. And with h, well, once again, we can put a 1 there, saying that this is m to the first power. We add these, so we have 6 plus 1, which is m to the 7th power. Now, if we take a look at dividing exponents, well, if I had 2 to the 5th divided by 2 to the 3rd, well, I can write it out as my 5 2's, 1, 2, 3, 4, 5, because that's what 2 to the 5th means. And then we have our 3 2's, 2 to the 3rd. And then what happens when we have the same number in the numerator and denominator? Well, they actually cancel each other out. So we cancel these 2's out. We cancel these 2's out. We cancel these 2's out. And we couldn't replace them with 1's because it's 1 times 1 times 1. But what we have left is 2 2's, which is 2 to the 2nd power. And these would all be 1's also, but 1 times 1 times 1, it just gives us 1. So we're left with 2 to the 2nd power, since those 2's all canceled each other out. So how about this one? Well, if we look at this example, x to the 6th, well, that'll give us 1, 2, 3, 4, 5, 6 of them. and then x to the fourth. 1, 2, 3, 4. And now, if we want to simplify this, well, these are all going to cancel out. So the x's cancel out. And now I'm left with 2, and they're in the numerator, so it's just going to be x squared. Now you ask yourself, is there an easier way to divide our exponents? There certainly is, because what you're essentially doing when you cross these off, we're subtracting them. So the quotient of powers, the quotient of two expressions with the same base, it has to have the same base, equals the base raised to the power of the difference of the exponents. So we're subtracting them. So we have c minus d here, and we have 15 minus 6. Now if we go to try these, once again, same base, so we can subtract the exponents. So we have 7 minus 2, which is 11 to the 5th. Same base, so we can have 4 minus 3, which is 8 to the first power. Same base, so we have y, we have 8 minus 5, which is y to the third power. We have the same base, so we can subtract them. 9 minus 4 is 5 to the fifth power. And now we can do the same thing for these ones. So we have x, same base, we have 5 minus 2, x to the third. With our y's, we have the same base, so we have 15 minus 7, y to the eighth. Same base, but once again, we have 4 to the fourth, and now I can just say this is 4 to the first power, because there's one 4 there. So we have the same base of 4, so I can do 4 minus 1. 4 minus 1 is 3. And with h, we have the same base, so we can subtract these, and 8 minus 1 is 7. So that's our property of dividing exponents with like bases. Now when we look at the next one, well, what happens here? Well, if I have the same base, so I can use the property that I just did, and I can do 3 minus 3, which is 7 to the 0 power? Well, that's kind of confusing. So it's 7 to the 0 power. Well, what if I would actually write these out? 7 times 7 times 7, 7 times 7 times 7. Well, now I can cross them off, because 7 to the 0 power, that didn't make sense. Well, this one crosses off this one, and we leave a 1. This one crosses off this one, we leave a 1, because 7 divided by 7 is the same. We divide them by 7, so we're left with 1 over 1. 7 crosses off with 7, so we're left with 1. Well, 1 times 1 times 1 is 1, and 1 times 1 times 1 is 1. Well, 1 over 1 is 1. Well, I got two different answers. I got 7 to the 0 and 1. Well, so that has to mean 7 to the 0 power is equal to 1. Well, let's take a look at this one. Well, we have H, 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 and H. Well, these cross off. These all cross off. Well, so it's 1 times 1 times 1, so I have 1, and 1 times 1 over 1. 1 over 1 is equal to 1. Well, if I look at this again, same base, so I can do 5 minus 5. Well, 5 minus 5 is 0. So h to the 0. So once again, I got 1. So 7 to the 0 is 1. H to the 0 is 1. So what happens when we divide a number by itself? Well, we get 1. So what we need to know about the exponents, anything raised to the 0 power, anything raised to the 0 power is 1. Anything raised to the 0 power, h to the 0, is 1. So anything raised to the 0 power is 1, except x cannot equal 0. Anything to the 0 power is 1. So x to the 0 is 1. Anything raised to the 0 power is 1. 5 to the 0 is 1. P to the 0 is 1. Now when we look at this one here, this is m to the third divided by m to the second and m. If I put a 1 here, I put these together, so this is going to be m to the third divided by m to the third, which is m to the 0. 3 minus 3 is 0. Anything to the 0 power is 1. And then we can look at this one. Well, this is 5 to the 5th and 5 to the 2nd. We put the numerators together, so this is going to be 5 to the 7th divided by 5 to the 5th. 7 minus 5 is 2, so we get 5 squared. And now we have these extra. Try work on these 10 problems, and we're going to go over them on Monday in class. And that was the first 3 laws of our laws of exponents. We have the multiplication property, division property, and power of 0.